several hypotheses to explain this paradox. One is the rare earth hypothesis. This suggests that the emergence of complex life is exceedingly rare and requires a combination of numerous, highly specific conditions, making Earth uniquely suited for life. Another hypothesis is the Great Filter. This theory proposes that there's a stage in the evolution of life that is extremely difficult to surpass. This filter could be behind us, for example, the emergence of life or intelligent beings, or it could be ahead of us, self-destruction or technological collapse. This kind of leads into the third hypothesis, which is technological singularity or self-destruction. Advanced civilizations may develop technologies that lead to their self-destruction, such as nuclear weapons or environmental collapse, before they can communicate with or travel to other stars. The zoo hypothesis suggests that extraterrestrial civilizations are in fact aware of us and have, for whatever reason, chosen not to contact us, perhaps just observing us like animals in a zoo, thus the name. There's the hypothesis of signal dispersion. States that the signals from extraterrestrial civilizations might be too weak or dispersed over vast distances to be detected by our current technology. There's also the hypothesis of cosmic quarantine. Advanced civilizations might intentionally avoid contact to prevent cultural contamination or harm to less developed civilizations. My thoughts on the issue. Well, let's look at, we have VR technology right now. We have AI technology. You've seen how far that has come in just the last few years. I would think that a civilization capable of interstellar travel would have first been able to create VR so lifelike that they're essentially able to create an absolute paradise on their respective worlds. Thus, there's no real reason for them to ever want to leave. So, having outlined the Fermi paradox, let's look at the mathematical likelihood of life on other planets. This is usually explored through the Drake equation, formulated by Dr. Frank Drake in 1961. The Drake equation is a probabilistic formula designed to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. The formula is N equals R star times F sub P times N sub E times F sub L times F sub I times F sub C times L. In this formula, N is the number of civilizations with which humans could communicate. R star is the average rate of star formation in our galaxy. F sub P is the fraction of those stars that have planetary systems. N sub E is the average number of planets that could potentially support life per star with planets. F sub L is the fraction of planets that could support life where life actually appears. F sub I is the fraction of planets with life where intelligent life evolves. F sub C is the fraction of civilizations that develop technology to communicate. And L is the length of times such civilizations can communicate. So let's look at these factors in a little bit more detail. R star, the rate of star formation in our galaxy is estimated to be about 1 to 3 stars per year. So this provides a steady stream of new potential solar systems. F sub p, the fraction of stars with planetary systems, is now known to be pretty high. With the discovery of exoplanets, recent studies suggest that nearly every star hosts at least one planet, making F sub p close to 1. In sub E, the average number of planets that could support life per star with planets is informed by the discovery of exoplanets in the habitable zones of their stars. Scientists estimate that there could be at least one such planet per star, giving a potential value of around 1. F sub L is the fraction of planets that could support life where life actually appears. This remains highly speculative. On Earth, life emerged fairly quickly once the conditions were right. This suggests that F sub L could be significant. However, without data from other planets, this factor remains completely uncertain. F sub I, the fraction of planets with life where intelligent life evolves, is another speculative one. Intelligent life on Earth took billions of years to develop, indicating that this process might be slow or exceedingly rare. F sub C, the fraction of civilizations that develop technology to communicate, depends on numerous factors, including the development of science and technology and that civilization's desire to communicate. This is another area with significant uncertainty. L, the length of time such civilizations can communicate, is probably the most uncertain factor. It depends on the lifespan of technological civilizations and their ability to avoid self-destruction or other threats to their existence. Given these uncertainties, the estimate for N, the number of communicative civilizations, vary widely. Some optimistic calculations suggest there could be thousands of civilizations in our galaxy alone, while more conservative estimates suggest that we might be the only one. Beyond the Drake equation, let's consider the statistical implications of the vast number of stars and planets. Our galaxy, the Milky Way, contains between 100 to 400 billion stars, and recent estimates suggest there might be about as many planets. If we consider just the observable universe with its estimated 2 trillion galaxies, each containing billions of stars and potentially even more planets, the numbers become mind-boggling. Even if the probability of life arising on any given planet is extremely low, the sheer number of opportunities for life to develop is astronomically high. Pun not intended. This statistical perspective suggests that life should be common. However, the vast distances and timescales involved complicate our search. The nearest star system, Alpha Centauri, stars and planets suggest that life should be common. The Fermi paradox reminds us of the challenges and the mysteries involved in detecting or contacting extraterrestrial civilizations. As we continue to explore our galaxy and beyond, each discovery brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? Until then, the search for extraterrestrial life remains one of the most exciting